Hey everyone, and welcome to The Explainer. All right, today we're going to tackle one of the most important ideas in all of artificial intelligence, supervised machine learning. So let me just ask you something. How would you teach a computer to tell the difference between a cat and a dog? I mean, you can't just tell it one goes meow and the other goes woof. You have to show it. You have to show it thousands, maybe even millions of examples. And that, right there, is the exact problem that supervised learning was built to solve. The easiest way to wrap your head around this whole thing is with a really simple metaphor: a teacher and a student. This one idea is going to be our guide through this entire explainer. So what is supervised machine learning, really? Well, simply put, it's a process where we teach a computer model by feeding it a ton of data where we've already given it all the right answers. Every picture of a cat is labeled cat. Every photo of a dog is labeled dog. This labeled data is basically the answer key. It's what the teacher, that's us, gives to the student, our computer model, so it can check its work and learn as it goes. Okay, but here's the really crucial part. The goal isn't just for our student to memorize the answer key. No way. The real goal is for it to understand the deep down patterns, the things that make a cat or a dog, so well that it can look at a brand new photo it has never, ever seen before and get it right. That's the true test of learning. Right, so just like any student, our model isn't just learning one thing. It can actually take on two main types of problems. You could almost think of them as two different school subjects. And here they are, side by side. First up, on the left, you've got classification. Think of this as just sorting things into clean, separate buckets. Is this email spam or not spam? It's one or the other. Did the customer make a purchase? Yes or no? The answer is always a fixed category. Then, on the right, we've got regression. This is all about predicting an actual number on a sliding scale. We're not asking if a house will sell. We're asking for exactly how much. What will the temperature be? What's the stock price going to be? It's about predicting a specific value. Okay, so our student has its subjects. Well, it's also going to need different ways to study, right? Different strategies for learning. In the machine learning world, we call these learning algorithms. Now, I know the word algorithm can sound kind of scary, but don't let it throw you. Just think of them as different textbooks or different methods for tackling a problem. A decision tree, for example, is super intuitive. It basically just learns by asking a whole bunch of simple if this, then that questions, building a little float chart that leads it straight to the answer. And this just gives you a taste of the sheer variety of tools out there. You've got algorithms that are specialists, like linear regression, which is great for predicting values. And then you have these versatile all-rounders, like decision trees, that can handle both classification and regression. It's like having a whole toolbox, and you just pick the right tool for the job. All right, we've got our student, we've got their subjects, and we've got their study guides. So now let's actually walk through the school year, from the first day of class all the way to the final exam. This right here, this is an absolutely critical step. We take all of our labeled data, our whole library, and we split it up. Usually we use about 80% of it for training. This is all the homework, the quizzes, the study material, complete with the answer key. But we keep the other 20% totally separate. We hide it. That 20% is the final exam. It's filled with questions our student has never, ever seen before. And this is how we find out if it truly learned or if it just memorized the answers. So all of this builds up to a pretty clear step-by-step process. First, you get the textbooks ready. That's our labeled data. Then you split it up for studying and for the big test. Next, the model picks its study strategy, that's the algorithm, and hits the books. After that, it's exam time. We grade its performance on that unseen test data. And finally, if it passes with flying colors, it graduates and gets sent out into the real world to do its job. Okay, so after graduation, what happens? Every student gets a report card, right? And supervised learning is no different. It has some amazing A+ strengths, but also a few areas noted for improvement. So let's start with the good stuff, the A+ highlights. When it's trained well, supervised learning can be unbelievably accurate. It's the engine running behind some incredibly complex things we use every single day, from detecting credit card fraud to recognizing your face in a photo. And because we have that original answer key, we can measure its performance very clearly. We know exactly how well it's doing. But of course, it's not all perfect. There are a couple of really big challenges. The number one risk is something called overfitting. This is just like a student who crams for a test by memorizing the exact answers on the practice sheet, but they never actually learn the concepts. They might ace the practice problems, but they're going to completely bomb the real exam. And on top of that, this whole process needs a ton of high-quality labeled data, which can be super expensive and take a very, very long time to create. And really, this quote just nails the whole point of everything we've talked about. It's not about memorization. It's all about generalization. It's about the ability to take what it learned from its teacher and apply that knowledge to totally new, totally unpredictable situations out in the real world. That's the whole game. And that kind of brings us to our final big picture thought here. The model is just the student. We're the teachers. We design the curriculum, we provide the textbooks, we make the answer key. So if our computers are learning from the data we give them, the real question is, what are we actually teaching them? Something to chew on. Thanks for joining us on The Explainer.